Assalamualaikum, salam sejahtera. Okay, we still on exercise 3, but on question 5. Okay, we now on question 5. Okay, so question 5, okay, is about okay, how to about a circuit. Okay, is shown in in a figure. Okay, so a coil loads and a motor are connected in parallel, okay, to a voltage supply. Okay, so if you refer to these circuits, okay, so you have a coil of load, okay, coil load, okay, coil load is here, okay, motor load and a motor load, okay, so this is the motor load, okay, with the M symbols here, okay, are in parallel. Okay, these two components, okay, are in parallel, are connected in parallel with your supply voltage, okay, 240 volt with 50 hertz frequency. Okay, so this coil load, okay, has a resistance of 6 ohm, okay, the price here, okay, and a 63.6 millihenry inductance. Okay, so this coil load, okay, consists of two. Okay, consists of resistance and inductance. Okay, so meanwhile, okay, the motor load taking a current. Okay, so this motor load, okay, taking a current IM of 5 ampere. Okay, so this load have, okay, 5 ampere currents with 0.8 lagging power factor. Okay, so this is the all the information, okay, given, okay, for this circuit as illustrated here. Okay, so the first question, okay, is to determine the magnitude and angle of the load current. So the load current, okay, is the I flow in your coil load, okay, the first branch here. And then determine the magnitude and angle of the supply current. So the supply currents, okay, is the I, okay, that flow from your voltage source here. Okay, so the question also, okay, want you to determine the active and reactive power delivered to the coil load. So the coil load here, okay, so you have to determine the active and reactive power. Okay, and then the next, okay, is to determine the active and reactive power delivered to the motor load. Okay, for the motor load also, so you have to find the active and reactive power. And then the following questions, okay, you also have to find the total apparent power here. The total apparent power, okay, is the power, okay, the apparent power, okay, from your coil load, okay, plus with your motor load. Okay, so draw the phasor diagram, okay, for the total current and voltage supply. Okay, and then the next question, the last one, is you have to determine the overall power factor value. Okay, so we see it on the solution. Okay, so from the figure, okay, the first question, okay, want you to determine the magnitude angle of the load, magnitude and angle of the load currents. Okay, so the load current or the coil, okay, the coil load currents, okay, the IL, okay, at the first branch, okay, from the given V is equal to 240 volt, okay, if you refer back, okay, to the previous figure, right? So the next information, you also have the R is equivalent to 6 ohm and the inductor is 63.6 millihenry. Okay, so in the first place, you have to determine, okay, the XL or the reactance of the inductance, okay, which can be found from using this formula 2 pi FL. Okay, the F is given as 50 Hertz. Okay, so 2 pi times with your inductor is 63.6 millihenry. So this XL, okay, you get 20 ohm. Okay, so you get the ZL. Okay, ZL is because in the coil load, okay, so you have the resistance and the reactance of inductance, right? Okay, so R plus JXL. Okay, the R, okay, is given as 6, okay, plus with your inductance here is J20. Okay, because you have inductance, so you have plus here, plus J. So in phasor, okay, phasor form, your ZL is 20.9 with 73.3 degree ohm. Okay, 73.3 degree angles in ohms. Okay, so your IL, okay, is because they are in parallel, right? So your V, okay, for your coil load is the same, okay, as what, okay, you get for the V sources. Okay, so the V load is equivalent to V source is 240 with 0 degree. Okay, divided by, okay, your ZL. Okay, your ZL is 20.9 with 73.3 degree. So your IL, okay, is 11.5, okay, with minus 73.3 degree ampere. Okay, so determine the magnitude. The next question, okay, determine the magnitude of the angle of the supply current IT. Okay, so now the supply current, okay, if you see back to the figure, okay, in the questions, so the IT is the summation of IL plus with your IM. Okay, so IM, okay, is given in the question, okay, is 5 ampere with 0.8 lagging power factor. So if, okay, the power factor is lagging, so you have to put minus cos, okay, the inverse of cos, okay, 0.8. So definitely you will get, okay, in terms of phasor, so is 5 with minus 36.90 degree. Okay, so the I supply, okay, is the summation of the IM plus with the I load. Okay, so the IL here is 11.5, right? With minus 73.3 degree. So you plus with your IM is 5 with minus 36.9 degree. Okay, so you will get the summation of these two currents, okay, which is the I total, give you the I total is 15.8 with minus 62.5 degree ampere in phasor form.